Okay, welcome to the lesson on permutations with identical items. So we're going to start with an example that you've already seen, or you should be able to answer. So how many permutations are there of the letters in the word, and we're going to do a bunch of parts. So A, the word will be Rome. So it's 4 objects. We're arranging all 4 of them. So hopefully you recognize this as P, 4, and we're arranging 4. So that's just equal to 4 factorial, which is equal to 24. Now B is going to be the word room. So you might say, okay, again, there's 4 objects, we're arranging all 4, so shouldn't there be 24? The problem in this example is that there's 2 O's, right? So when we came up with the 24, it's treating these 2 O's as distinct objects, as totally different. But really, they're not. If they were distinct, let's say this is O1 and this is O2, well then this, the 24 permutations we came up with up there, that's going to include, let's say, R1, R01, O2, M, and R02, O1, M. It's going to think that, these 24, these count as 2 different things, but really they're the same, right? R-O-O-M, R-O-O-M, that's the same. It doesn't matter if O1 is before O2 or O2 is before O1. Similarly, it's going to have, let's say, R1, R01M, O2. That's going to be the exact same as R02M, O1. Same as RM, O1, O2, RM, O2, O1. So, these are the same, these are the same, these are the same. We just flipped O1 and O2. And I'm not going to list them all. I'm not going to list all 24. But hopefully you'll notice that for each, in these examples, O1 is always before O2. And that's going to correspond with another arrangement where O2 is before O1. So each permutation with O1 before O2 has a matching permutation or a corresponding permutation with O2 before O1. So if each one of these has a matching pair, how many extras are we counting? So therefore, half the arrangements, or half the permutations, are duplicates. Right? Since half of them have O1 before O2, and the other half have O2 before O1, and they each match up, are duplicates. So if half are duplicates, then what do we have to do with this number 24? We just need to divide it in 2. So therefore, there are 24 divided by 2 equals 12 unique permutations. So when we had 2 O's, we had to divide by 2. Let's see, what about the word sus? SUSS. So here we have three letters which are identical. So you might say, okay, when there's two, we divide it by two. So maybe we just divide by 3 in this case. And that'd be a good guess, but not quite right. So again, let's number these S's. So let's say S1, U, S2, S3. So that's one permutation. But that's going to be the same as the permutation, let's say S1, S3, S2. So that's the same, but it could also be the same as S2, U, S1, S3, S2, U, S3, S1, or S3, U, S1, S2, and S3, U, S2, S1. So there was 1, 2, 3, 4, 5, 6. 6 identical permutations, right? All these permutations are just SUSS, even though it's a different numbered S. So it's not unique pairs, right? Remember when each O1, we just flipped the O1 and the O2s, so there's twice as many? Here, we're arranging these three S's. So there's actually 6. Why was there 6? So some people might say, okay, there's 3 S's. And really all I did was, I did permutations of those S in the different positions, which is equal to 6. That's why I got 6 identical permutations. And then you could also do, let's say you had the U first, S1, S2, S3. And then there's going to be 6 more exactly like this. You're just going to do permutations of these 3 letters and leave the U in the front. And similarly, where else could you put the U? S1, S2, you could put it there. Now, there's going to be 6 more exactly like this. You're just going to do permutations of those 3 letters, and then the same S1, S2, S3, and we're going to put U at the end. Just the permutations of these 3 letters. So really there's just this one, this one, this one, and this one. There's just 4 permutations. And then each of them has sort of 6 corresponding. There are 4 unique permutations. You could list them. We already did S U S S S U S S S S U U S S S with 6 corresponding or matching permutations. Each. So really there's just the 4. There's 4 unique, and the other ones are all duplicates. So how did we get the 6 from the 24? Remember, if we did 4 factorial, right, there's 4 objects, then we just divide it by this 6, which really we just got by doing 3 factorial, which is just equal to 4. So when there was 2 identical objects, we divided by 2, which you might notice 2 is actually just equal to 2 factorial. When there's 3 identical objects, we divide by 3 factorial, or 6. Okay, now we got the word maximum. So how many identical objects do we have? 3. There is 1, 2, 3, 4, 5, 6. N is equal to 7. So there's 7 objects we need to permute. So it will be 7 factorial over how many identical? 3. 3 factorial. So hopefully we know this is equal to 7 times 6 times 5 times 4, and that's it, which is equal to 840. Okay, and one last example. E solves maximum. Let's do the word minimum. So what you might notice here is that, okay, we still have 3 m's, but I also have 2 i's. So what do I do with that? Not too hard. Again, there is 7 letters, right? So since we have 3 m's, we better divide by 3 factorial. But we also have 2 i's, so we're also going to divide by 2 factorial. So that works out to, I don't know, let's say 7 times 6 times 5. There's a lot of different ways you could sort of do the algebra to get this. But it's 420 should be your answer. So there's 420 unique permutations. So let's just kind of write that down as a formal rule. So the number of unique, so that's important, permutations of n objects where a, so a will be a variable, are alike or identical and b objects, so b is a different type of object, so b objects are alike, etc. So you could have C you could have as many different groups of objects alike. Is, so you're just going to do n factorial over a factorial, b factorial, then if you had a c factorial, etc. So just to explain this definition, just look at that previous example we did. So n was 7, so we did 7 factorial over, so a objects are alike, so 3 m's, so a was 3 because there were 3 m's, b was 2 because there were 2 i's, then we didn't have any others, so we stopped there, so it's just 7 factorial over 3 factorial, 2 factorial. If there was another group of letters that were the same, we'd multiply that on the bottom, and that's it.